Good afternoon, everyone. Thanks for attending my talk. My talk's going to be on DevSecOps. When it's not a buzzword when you have the goods, right? So we're going to go over a few things. It's like the weirdest, longest title ever. So I apologize if I ever had to type up any kind of agenda for today. So, all right, who am I? My name is BryanDavies. I've been in the software world for over 20 years. I've been a developer for most of it, actually, manager, director in sales. I've done a lot of investigation of insecure code. I've done a lot of product management stuff and designing secure systems. So I kind of have a little bit of experience in kind of all the areas, I guess. And I currently am an SE and I work at Splunk. All right, so what's my talk about? Well, a big thing I want to focus on when you start talking about DevSecOps, first off, a lot of people don't necessarily know what that means. But I also want to talk about the idea that production is too late, right? And that's going to be a big part of my talk today. I'm going to talk about what can we do about it. Then I'm also going to share some resources with you guys. So it's a talk it's for you guys, for developers, operations teams, security teams. And just out of curiosity, I know there's a lot of students that are going to today's talks. How many students are in here today? So like a group. Okay, good. And the students, are you mainly in security world, operations, cybersecurity? Okay, so there'll be some stuff in here for you. So, all right, and one thing too, if we got the subs going for later, going to be a dance party at the end, be a surprise. But if you guys have questions during, please don't be afraid to interrupt me. Okay, I'm going to be going through a lot of stuff, going kind of fast. Just please interrupt me. You don't have to save them to the end. Okay. All right. So why am I giving a talk? Well, I guess I'm a sucker for punishment. I did one last year, so I'm going to do it again this year. It's actually quite enjoyable. Did a lot of work to put them together, but not as much as what James is dealing with. So, but the big reason is the containers and microservices, right? They help us scale our infrastructure. They help us scale our applications, but they also massively scaled our problems, right? They introduced a lot of problems that never existed prior to using those systems. Okay, so what is the problem? I'm going to go over first some of the stuff we know. So we got the little sleepy red panda. You know this stuff. This is the boring stuff. Don't have to worry about it too much, right? We still have security bugs going into production. Performance issues are still in production, right? We're still doing last-minute changes to infrastructure. Who hasn't done a midnight patch, right? They suck. I don't know if you've ever had to do those for the students. It's a terrible thing. It's always a panic. You can never get a hold of people. There's no food. You're stuck in the office. You can't get anything. Like it's a nightmare. So containers, in theory, they're easy, right? It just works. It's magic. They're light. They don't need much IT resources. They set up right away. They disappear. They clean up. They're really, really nice. However, that's not the reality. Container management is super hard. Right? Containers can crash and disappear and you don't even know. There's no indication that container is even running unless you're capturing the logs, which a lot of people aren't. They just go up, spin up, and then they're gone. So you have an error in an application, you've lost all that information. You don't know what's going on. The other side effect of containers is we started using microservices for our architecture. That's also really hard. It's complex. It's such a disaster to try to troubleshoot a microservice because these containers going up and down while you're trying to trace something through. Like it's really, really hard. And like another side note that a lot of people don't even realize, containers are so lightweight because they share the OS kernel, right? So if you haven't patched your OS, you essentially haven't patched any of those containers, right? Everyone thinks they're just kind of magic and they're off on their own. Oh, they're fine. They're going to be good. But they do rely on the OS kernel, so keep that in mind. All right, so we have this mess, and we're going to add people to the problem. When does that always work, right? Adding more people to an issue. First, we're going to add the development team. So what do they do? What can they, like, what are some of the things that we have to deal with the development team, right? Are they actually testing for security problems? I don't know if we have any developers in here, but testing for security was like, that wasn't a thing. It's even now for a lot of shops, that's not a thing, right? Are you tracking the infrastructure changes that you're doing to UAT? That's a weird thing about the operations and dev groups. They have this weird understanding that UAT is for the developers, everything else is the ops team. So the UAT environment, developers can change stuff in, but they don't always track those changes. and then all of a sudden it gets deployed. Well, you have a deployed area that doesn't line up with the UAT test area, right? And development teams don't really monitor containers. They don't have the tools to. All the stuff around developers is all about the local debug or even some remote debug. They don't have a lot of stuff for handling containers. The security team. So do they actually share what they find? Security teams like to be secretive. They like to take all this stuff, and it's like their bonus is dependent on how many times they bust into the systems, right? You got to share that information. If you don't share that information, it can't be fixed. So that information has to be shared, and it has to be shared in a usable format. If you just tell a developer, hey, we broke into your system.
I'm sorry, can you speak just louder?
Yep. Oh, sorry. I'm standing back from my. If you don't tell the developers that you've broke into their system, how can they fix that problem, right? So that's you just got to share that information, right? And the other thing that security teams sometimes run into, and this is the operations team too, but is UAT and staging, are they set up the same? Right? If, again, it kind of goes back. You could potentially be testing in an environment and deploying it to something that's completely different. Okay. And the operations group, are they actually monitoring your UAT and staging? As I mentioned, I should go back for a second. UAT, does everyone here know what UAT means? There's a bunch of students, right? User acceptance testing. It's typically from a dev world. That's where they do everything. That's their last stop before it goes production. Okay. So is the operations team looking after UAT? Because again, that's kind of your last stop to find performance problems, right? Or sort of architectural problems, okay? And then again, who actually owns changes to the UAT environment, right? And is the dev team, are they working with the operations team to figure out what the design should be? This is actually a pretty common problem. Devs like to just kind of do things on their own. Developers like to work at different hours in operations team too. They kind of do magic stuff in the middle of the night. All of a sudden they get inspired. So you can't really share that information with an ops guy to help you figure out the best path if you're working those hours. So you end up with two worlds, a product world and a corporate world. Okay. Product world, what the development teams care about. That's basically, where does the product live? Where does the product get ironed out? Right. That's the UAT staging. And then you have the security and operations team. They worry about the corporate world, right? They're worried about threats. They're worried about performance. They're worried about, I have a client-facing application. It cannot go down. I have to make sure the data is secure for it. I have to make sure that we don't have insider threats that are trying to steal our stuff and work for a competitor. They care about that, the corporate world. They kind of leave the UAT world completely alone. And vice versa, the developers don't care at all about the corporate world. They don't care about the accounting system. Right? They don't care about any of that stuff. They care about their little UAT world. So you end up with siloed teams using siloed environments. So the result is essentially a mess, right? Again, the security group only cares about corporate. So they only test their security controls against the corporate. If you have an application that's potentially being sold into certain companies, you might have to follow certain audit requirements like CSOC audits or PCI audits or whatever. So that would be the one time the security team will come in and work with you to do audits. Other than that, they leave you essentially alone. The infrastructure performance is only tested again in the corporate world, right? They don't only care about, like, do the clients, if they're trying to purchase my whatever system I'm selling, is my cart going to survive? I don't care if it breaks in production. No one's, or in the staging, no one's actually buying that. I only care if it breaks in production. So you have these two groups looking after two worlds, and then they don't really share any of their findings, which is another problem. Oddly enough, that's a finding or a kind of a common theme I've been seeing in the other talks. There's been a lot about kind of sharing knowledge in the B-sides this year. Okay, so the real problem is production is too late, right? You can't, I'll get into it, but like it's too late. You got to solve these problems before you get into production. So there's stuff you know about this, right? Fixing production is expensive. If you are a company that's selling stuff, e-commerce, if your production site's down, that's bad news, right? It's very stressful on the teams. I know people that have quit their jobs because their production environment was too just broken all the time. All they're doing is working at night, working nights, weekends. It's a very stressful environment if your production site's broken. It's always middle of the night. It's always hack fixes. Who here has actually done a proper middle of the night fix in production? Oh, one guy. Two. Was it after a hack fix and you kind of figured out, hey, I can patch this a little bit better? Yeah. It's always the hack fixes. And if it kind of works, you're like, I'll solve it in the morning, right? So you've kind of hacked together a fix and then gone back to sleep for a few more hours. have you actually fixed the problem, or maybe even introduced another one, right? Because you've just kind of got it limping again. So that's also not necessarily the best way. And you always need multiple teams, right? If you're doing these middle of the night things, there's always one more guy you need to get a hold of, one more girl you got to call. Like there's not enough people, and they're never around. They know it's broken. They've turned their phones off, so they're not going to answer. So again, yeah, production's too late, right? A Black Friday outage can result in tens of millions in lost revenue, right? I know one company, they had a payment service that went down for an hour during Black Friday, and they estimate that was well over $10 million, 1 hour. So, they were able to, they had the proper systems. They were able to see it and reroute it. They knew within 5 minutes what the problem was. It was just the rerouting of the payment service. That took a while, but still, they were like 1 hour, $10 million, they figured. Data breach cannot be undone, right? If it's gone, it's gone. It's out there. You can't go and collect it all. And critical infrastructure, it can't recover. And I don't mean like, your network. I'm talking about stuff like pipelines, bridges that have like the bridges that let boats go underneath them, hospitals. Right? That's what I'm talking about when I mean critical infrastructure. If someone brings down a hospital with a ransomware attack, it's not just the next day it's up and running fine, right? There's a lot of problems with stuff like that. All right, we're going to go on a bit of a story, take you on a little bit of a path here. So, who uses a WAF? A couple of hands, okay. Web application firewall, for those who don't know. How many rules are turned off? I see some snickering. So there's rules turned off, right? Because it doesn't work otherwise. Otherwise, it just stops everything. The proper WAF lets in zero traffic through. That's kind of how they work. So out of those rules that you have turned off, how many are injection rules? Right? A few? A couple of heads nodding. They're the harder ones to kind of work around from a software perspective, typically. That's why they end up kind of getting left on. All right, so we have a WAF. We have some rules turned off, and it's injection related. So are you monitoring your web request logs, your application logs? Potentially, you might even have some other firewall logs, even though they're not going to see all that information. If you're going to turn off a rule, how are you kind of watching it? Right? How are you watching what you just disabled? So you can do things like watching your web requests. Okay, now the other thing, this is really important. A lot of people kind of overlook this. All the WAFs I've ever used, anyways, there might be some that don't do this. You have 3 options with a rule. You can block it, you can disable it, or you can log it. So what's the difference? Disabling is what most people do. They just turn it off. I don't even care about this rule. I'm just going to turn it off. But instead, you should log it. That means if the WAF still triggers it, saying, hey, something's going on, it at least puts a note in the log. So your security teams can find this stuff later. Right? Too often you see people, just turn it off. We don't need it. Like, we don't care about PHP injection because our site uses .NET. Let's just turn that rule completely off. Well, you still may want to log it, right? So that's just one of those little things just kind of keep in mind. So in this scenario, we have some rules turned off, right? Just disabled completely. Then the audit comes, right? And they find these. They always do. They always find and complain about all the stuff that you don't have turned on. The rules are turned back on. They test it. Everything works. Oh, okay, well, maybe that rule, maybe we fixed it. We didn't even know. Maybe that one release, when we switched the framework, it's all good. Off it goes to production. All right, now it's problem time. Okay, the checkout process starts to randomly fail. It doesn't fully fail, just randomly. And not very often. Again, it's just random light failures. So it's like, well, maybe it's that rule. But at the same time, when we enabled the rule, did we push any other code? Did we do anything? What's going on? You start looking into it. You see orders are being abandoned, not completed. You dig into it a bit more. You can start to see that, well, like what's going on? They're starting to time out. So what's starting to happen, right? So what is that? Well, it's your always popular free-form text box, right? And you see this on every checkout. Shipping instructions, special shipping instructions. Leave at neighbors, '*S. Oh, the apostrophe. That always trips up a WAF, right? Like it just looks for an apostrophe, okay. But anyway, people use special characters in those boxes. They'll maybe put like the $10 is under the rock, and then there's a $sign in there now, right? So whatever, but those special characters will trigger WAF. And now that you've turned that rule back on, this shipping box is starting to trip up the WAF, but only in certain situations. This is a really hard problem to find, right? And then what happens, right? You have things that are timing out. What happens to your customer? I've been sitting here for like 30 seconds in internet time. This might as well be 3 days, right? They'll go somewhere else. Oh, well, Best Buy also sells it. I'm going over there. Whatever. Their site doesn't pause on me delay. So now you're broke, right? Because your site's no good. It's stopping all these things. And again, it goes back. Production is too late. You have to catch these ahead of time, right? You can't just wait and hope they catch them in production. So what can we do? How can we fix this? Pause for a second. I need to drink the water. All right, stuff we know. We're already doing this. We've seen talks in this stuff even today. CI/CD, DevOps, unit tests. Infrastructure as code is a good one because that's starting to be a lot more prevalent, which is good to see. I don't necessarily agree that people are using it properly, but it's more my opinion. I'll get into that in a bit. Threat hunting, log monitoring, that stuff's all happening right now, which is good. Okay, so what do we have? In order to get better, I'm going to say, let's take a step back and say, well, what do we actually have? Maybe we don't need a bunch of stuff. So what do we actually have? The dev teams have a crap ton of tools. Profilers, more profilers, analyzers, like it's crazy. Debuggers, every IDE you can imagine, source control, right? They have a lot of things. Their tools are really focused on kind of the local world, though, right? Their system, maybe a dev test where it's a very minimal container system, or if it's more of a monolith, it's a smaller server, a single server instead of a server farm, right? That's kind of where their tools really, really shine. If your ops teams, they hopefully have infrastructure as a code systems, and I really hope their scripts are in source control. They're probably not, most aren't, but that's a really good habit. If you get stuff in source control, you can actually do iterative changes to your infrastructure as a code. You can go back, imagine. You won't have Notepad++ open 50 tabs across the top because it's every little change you've done while you're working through a problem, right? Ops teams have really good container performance monitoring systems, or at least they have some available to them, in-depth infrastructure. Like they have a lot of really good monitoring systems, right? And they have budget typically, not always, but more budget than a dev team. Security teams, all right, they have more open source attack tools than there are like JavaScript libraries, right? Like there's so many of those tools. It's amazing how many there are. They have really good monitoring systems, detection response systems. Security groups are really protective of their little world, though. Like they call it a SOC, right? Their Security Operations Center. No one's allowed in there. You're not allowed to see the tools they have. They'll tell you a report or maybe send you a screenshot. But there's some pretty interesting stuff, right? And they even have more budget. Like who paid for the SOC that they have, right? Like so they have some money, those guys. So if you're in dev or operations, become friends with your security teams. They have some neat stuff. Right, so now we know what we have. What can we do? We got to share this stuff, share the knowledge, share the tools. All right, I'm going to go through this a little bit. So source control. Developers know this inside and out. Operations team and security teams do not. Where are operations teams storing all their infrastructure scripts? Where are security teams storing all their attack scripts? Right? How many of you just have a folder on your desktop with attack script set 1? Oh, it's a Windows, so I have a Windows folder, right? Like why? If your machine crashes or whatever, it's gone. Like source control manages it and makes it easy. You hook that up with an IDE, and it's even better. IDEs talk to source control out of the box. You can do historic versioning. They call them diffs if you're a developer. So you can diff version 1 against version 20 and see all the changes. It's super powerful stuff. IDEs understand YAML. I mean, I don't even understand YAML, so it's helpful that an IDE does. And very recently, I was trying to help a company troubleshoot a YAML setup file, and I had to edit it in a Linux VM, like a GUI-less Linux VM, and I had to use Vi. And I opened this up in Vi, and I was like, oh my good grief, I don't even know. I was so frustrated trying to even understand the YAML file when it's just all showing up as just like one color, orange, and it's not really, the indents and the wrapping don't really look proper. I couldn't even remember how to exit and save. I had to go get like my quick Linux cheat book. Like it was so frustrating just to look at it. You look at this stuff in an IDE, It's color coded. It doesn't wrap the lines, so it doesn't, it doesn't mess up the indenting when you're looking at it. Because of course those indents are important. So when a line wraps, you're immediately drawn. Oh, here's where. No, that's not the problem. It's a line wrap. Anyway, so use IDEs. They work nice with source control. It just, the frustration level goes way down, way down. So developers, teach your other teams about these tools, right? Developers and somewhat the ops team also already use deployment systems. So like Octopus Deploy is a really common one. I use that one a lot. I actually don't even really know much about the other ones because I use that one so much. Those systems are great. They have release management. They have audit trails. Like they have approval process. So essentially you can also package stuff. So you can say this goes to UAT, and that package can be your entire infrastructure, your entire code base as well. It can be everything as one big thing. And if it fails, it'll roll it back. It cleans itself up. Those systems are really powerful. The operations group, they really need to benefit from making use of those. And most of those systems will actually manage things like Helm and Terraform, right? Helm and Terraform, yeah, they're powerful, but the front end management piece is a pain, right? Like, can you tell me if you looked across your infrastructure, which one of those VMs was deployed with the latest patch Windows versus 3 weeks ago patch? No, right? Well, I got one guy, you built something, didn't you? That stuff's hard, but that's like what these deployment systems are meant to do. That's what they do. They can show you this area has this version, and as long as you version your little packages properly, that's some of the stuff you can have. So log ingestion systems, this is going to be, well, I'm at Splunk. That's a big part of what Splunk does, log ingestion. And so an example, again, kind of going back to our story, and I've had to do this where I've had to match up IIS logs with a WAF log with an application Elma log. And if you don't have log ingestion systems, which I didn't where I was working at the time, you very quickly find out timestamps do not line up between these things. My IIS log was my local server. My WAF log was my cloud time, right? Which I think actually was UTF time. And then my Elma was was actually the database server time. So I had basically 3 timestamps across these things. And I was trying to find out, well, I know I have this problem. And it was actually a WAF error where it was an injection problem on an application. It took me just forever just to line up the logs, right? So that's why these systems are really helpful. But quite often operations teams have these. So here I was as a developer fighting with this exact problem that had I talked to the operations people, they probably had a tool that would just all work. Oh yeah, here you go. You can look at this and here's the stuff. So share these tools, share the knowledge, figure out how to kind of come together and show have like a show and tell or something inside. All right, container performance, devs definitely need this. They need to be able to see that when they release something. Is it getting better or worse? Some of these deployment systems and build agents, they can actually monitor performance and fail a build if performance goes down. So there's actually a lot of neat stuff in there. Your SIM, right? The pen test results. Are you sharing them with your development team? Right? Are you telling them the good news or only the bad news? Are you keeping some to yourself for the next time you're on a pen test you can get in? Right? So how can we be better? I hate acronyms. So we need like a common language. We're not going to get away from acronyms. Don't get me wrong. But for the students that are in the crowd, I'm not going to go through all these. You are going to see these a lot. This is just the app. I have 3 pages of this. So take a quick look. You'll probably run into these. You may want to learn them. If you want to take a picture of the screen, that's fine. But there's more. That's the application ones. Security ones. Some of these we even heard in a previous talk on MITRE ATT&CK. They talk about that actually in the keynote. SIM, SOAR, SOC. There's a lot of stuff around security. And then the operations, ingest, indexing, right? Site reliable engineering. It's like a job title. I'm sure everyone's now seen. Some of the neat ones about operations. I like the term they have, time to glass. I like that term. It's basically the time it takes for an alert to hit their dashboard. I don't know if every company uses that one, but that's one I've come across. I like that one. All right, so now we kind of have a bit of a common language. We kind of know what everyone has. We kind of know what everyone does. So we need to dream. And wouldn't this be amazing if your application, your infrastructure is tested for both security and performance before it goes into production? Can you imagine before it goes into production? That's like a dream, right? And not only that, but if you find a problem, you can actually track it down. There's kind of 2 sides to this. Like that's the other thing. Okay, one problem snuck through. Can we actually find it? Right. So how do we get there? How do we get to that dream? Well, we probably going to need a few more systems. Most companies will have these, like I said, already. It's just they might be siloed in a group, right? You probably have log ingesting and indexing, right? Splunk Cloud is an example. Elk, that's the open source. What is that? I can't even remember. Elastic. I can't remember. There's like 3 open source projects. If you just Google Elk, you'll find it. Anyway, your SIM, observability tools, Splunk observability, and open telemetry. Open telemetry is getting quite big. It's all open source. Their data can be collected into many different types of systems now. It's very, very powerful. Right, your SOAR tools and your attack frameworks. And there's a lot of attack frameworks. I'm picking on MITRE ATT&CK because I've used it. So the other ones I'm not using in here because I haven't used them, so I'm not listing them. There's a lot of them, but I'll show you some of the MITRE stuff in a bit. All right, so now we have these tools. We have everyone on board. We're going to try stuff a little different. Okay, so what do? Well, we start the same. Okay, devs still write the application. Okay, that's good. DevOps build deployment scripts now. So that's a little different. So we've got the ops guys helping. We're building some deployment scripts, but you're building them for both the application and the infrastructure. That's important. The infrastructure one's important. Right now, does anyone here build infrastructure scripts for UAT? 1, 2 hands. Not very many. Production? Well, 3 hands. I don't know. Okay. We have a little ways to go with this then. But the idea is you want to build them for both, because essentially, what is UAT? It's testing. What better way to test your infrastructure scripts than in a testing environment? Makes sense, right? So let's use testing for testing. Okay, so we got our scripts. Now security steps in. So the devs will work with the security teams to come up with security code analyzers. There is a ton of these as well. OWASP has a great list of them. If you look OWASP and search for code analyzers, you'll see there's like multiples for every language. And essentially, it's just a static code analyzer. It's kind of the bare minimum you can do to look at your security stuff, right? So there's probably a lot of people already doing this, right? Some build agents, servers have this already baked in. So you might be doing this already and realizing it. So you have your builds now. You have a quick security thing that's been checked. So now you deploy it to UAT. But you're going to deploy the UAT infrastructure as well. So basically, the old UAT is not there anymore. You blow it away. It's gone. You deploy a brand new UAT infrastructure, right? So all containers. Containers are easy. Remember that? It's easy. So we deploy all our UAT, brand new. On top of that, you deploy all your applications, okay? So now you have a brand new UAT infrastructure, brand new UAT applications. And again, if you use deployment systems like Octopus, a lot of this stuff's a lot easier. You try to do it manually, it becomes very, very frustrating, very fast, and no one will do it. You have to automate these types of steps, otherwise it won't happen. People will start going down that path and they'll abandon it. Okay, so now you have UAT, and it's like your new sandbox, essentially, right? Now you got all these tools, you can point them to the UAT, because again, remember, the end goal here is that production is too late. So you turn on your log ingesting, right? So all your UAT, it's going to have firewalls, it's going to have networks, you might even have an LDAP in there. If not, no big deal, you can still pull the main LDAP. You're going to have your sysmon, perfmon, you're going to have all these logs, right? So pull them into a UAT index in your log ingestion system. Okay, and those ingestion systems, they can be set up via infrastructure scripts, right? In fact, that's the most common way those systems are rolled out, because you're typically rolling them out to hundreds of hosts, right? So they already have a lot of that ease of use baked into them, right? Your SIM. You want a UAT SIM. So I don't know enough if you want to have a second SIM or if you want to have a second dashboard, second area, but ideally though, you want kind of a different set of alerts, different everything that's independent of your production and corporate environment, and just this little UAT SIM. However, you do want the same dashboards and same alerts, because again, what you're doing when you have stuff like the SIM set up, you're not just testing your application, you're also testing your SIM. Right? That's what's kind of neat about having a UAT environment. You're kind of doing a double test, right? If you set it all up and you do some tests later and your SIM has nothing, well, perhaps your SIM is set up wrong, right? Maybe your application isn't that secure. Maybe it is, but it gives you another thing. Maybe you should look at your SIM. Because again, if you find out that your SIM is not set up properly in production, guess what? It's too late, right? Observability. There's a lot to install, a lot to set up with observability. I'm not going to get into that. Observability, the concept is basically you're watching a product from the very beginning to the very end. You can watch the user at a website level. You can watch all that all the way through the application. You can watch its calls to the database. You can watch how that impacts containers. You can watch how it calls out to other sites. It's crazy. Observability systems see absolutely everything. It's like a profiler that developers already use, but on steroids, right? They're really, really powerful systems. And the reason you want to capture this, I'll get into a bit more, but this data becomes really critical in the UAT environment, which I'll get into. Okay, your security orchestration, automation, response system. This one's a little bit iffy, right? You may want to copy some of your playbooks into UAT, but if you do, you copied potentially production playbooks into UAT. So if something gets triggered, you might be turning off your production firewall. So if you're going to move a SOAR, maybe it's easier to set it up from scratch. I don't really know the best answer on this one yet, because some of these SOAR products are still a little bit more immature, so they don't necessarily have some of the flexibility. Some of the newer ones, though, some of the more updates, you can actually pull in like playbooks from GitHub, so you can have kind of a base starting point. So it might make it a little easier. But again, just be careful with this, because if you decide to copy it, then you do run the risk of actually running playbooks against your production versus UAT. Okay. All right. So now you have some stuff set up. Everything's ready to go. Okay. And that takes a lot of work. Don't get me wrong. That's to get there is a fair bit of work. But now that we're there, what do we do? Well, we'll start simple. We can run our UI tests, right? Developers already have these. They'll call them synthetic users. In fact, there's even systems that will run these for you. They'll call them integration tests. Essentially, the most common way of explaining it's the Selenium test that just fakes a user, clicks through the site, right? Who hasn't seen these? Super common. Most companies have tons of these already. But your system is now instrumented, as it's called. And that's when the hooks for the profilers for observability are in place. So now you can actually look at it on a system like APM. And you can see performance problems. You can see errors. You can see lag, latency. You can see these process maps that you're seeing here. These systems auto-build these. You don't have to build that. That's built based on the traces. So you can look at that and it's like, wait a second. Everything's working fine, but why do I have two payment services? One's called payment.old. That one's probably supposed to not be called anymore. You can actually see stuff like that. It's working fine, right? That would never trigger an error, but you can see that that's a problem by kind of looking at and investigating these tools. In this case, on the screenshot I have, you can actually see that red circle, and that's actually some errors that are occurring on a service. And so you can actually, but it's not always occurring. So again, you could have a scenario where some of your tests are erroring, but not all. And you can see the little path through, right, where the error is kind of coming from. So you can kind of do root cause analysis. Further in these types of systems, if you click on the map, you can actually see what containers it's running on, what versions. You can really get a lot of detail. And again, that depends on having the observability, the collectors set up properly. So it's really important. Next, you can run your load tests, right? So now all of a sudden you're going to just hammer the box. What happens? Well, again, with these observability tools, you can monitor your containers. What are they doing? You can start seeing them scale out. You can see them when they start turning on. They start getting color coded if there's problems. You can click into them and see what's going on. You can click into them and see what services are running on them. This container map and kind of the service map, you can kind of go back and forth. Most of these types of systems have something like this or similar. There's also, you'll see all the logs behind it. So if you see a red box and you want to click it, you can go just show me the details and you'll see the running list of events that are going. So you can just look at all the events, right? There's a lot of stuff that's available in these. And if you kind of set them up right, it makes it really easy from a graphical perspective to go through this stuff, right? Especially load tests, because I mean, there's just so much information from load tests. Okay, you can run the attack framework. So this one's pretty neat. So I'm sure a few of you guys have heard of Red Canary, right? They have an atomic red team. So they've taken the MITRE attack framework that exists, and they've actually made an attack system. You can just run it. There's actually, so that link there, it'll take you to their main GitHub page, and then there's a command line utility that'll run all of their attacks. The nice thing is it pulls them from GitHub, so as they get updated and changed, it'll just pull the next set of attacks. So you can kind of point that thing at your system and let it loose. Now, it will break things. So kind of be ready when you do this. Like, don't be like, okay, we're going to have the users, the actual end users are going to test tomorrow, but today we're running MITRE attack. Well, you'll probably destroy it before those guys get attacked. So just be careful with this. But it's really neat because if you do this, okay, and I've done this on a small scale and it's just so cool. Well, then your SIM will detect this stuff. Okay, most SIMs have plugins, add-ons, apps, whatever you want to call them, that actually monitor very specific attack frameworks. So in this case, this is the Splunk SIM, and we're looking at the MITRE attack app, right? And they're always freebie add-ons for these systems, right? Because it's meant to help you guys. And basically, what the MITRE does is it basically maps all the known attack vectors to known log hits, right? I guess that's the easiest. Like, there's a log pattern matches this attack. That's kind of what it's looking at. So when you run your attack vector, right, in UAT, this SIM should just light right up, right? If it doesn't, again, does that mean the SIM's set up wrong? Or does that mean your application is stopping everything, right? If it doesn't stop, if it just doesn't light up at all, it's probably something set up on the SIM, which again, so you're testing both the SIM setup and you're testing your application, right? And as teams go through this, they'll start to feel it out, and they'll start to see when things are kind of one way or the other, right? The other thing, when you run an attack framework, if you have SOAR set up, what did it do? Did it just start going nuts, shutting stuff down, right? For some things, it probably should have. So again, what's going on? Is it doing this stuff? But this also helps you test the infrastructure, right? The reality is most of this stuff should have been stopped before it made it in. So did that happen, right? So you have one attack happening in a UAT environment, and 3 teams are benefiting from this, right? And that's really the kind of the key part of what we're doing here, right? So now you've done all your attacks, you've done some log stuff. Now it's the red team's turn. Just let them loose. You've basically built them a safe place. Go break it. Go see what you can do, right? And they'll be, like I said, they'll be going to that little Windows folder on their desktop, double-clicking my little hidden scripts that I'm going to run, right? That should be in source control for the whole team. Anyway, they're going to run those, and they're going to see if they can get in, right? Well, again, you can monitor this attack. What did the red team do? What do we see when the red team's doing their things, right? Did the SIM show up stuff again? Did SOAR go crazy? Like, what happened? The important things, though, for both the SOAR product and the SIM products is know what to expect, right? Like I said, maybe you are actually expecting the SIM to see 0 MITRE attacks because you've hardened the firewall, you've hardened all the access points. There should be no way to get in, okay? So if that's your expectation, just make sure the team knows that as part of the attack, right? What are the expectations? Because that can be a little bit confusing if you're expecting to see a few things and you see 100, right? Okay, well, maybe we deployed the wrong thing. Maybe the infrastructure script's wrong. So just kind of have some expectations as what's going on. So now you've done attacks, you've done load balances, you've done all this stuff. You've actually collected a ton of data, right? So now it's the threat hunter's turn. A better way to train threat hunters than basically, hey, we ran a MITRE attack yesterday. Go see what you can find, right? Go dig through the log system, right? If you have a log ingestion system, you should have all this stuff for them. They should be able to go looking. They should be able to start looking, testing profiles and testing theories, right? So let them loose. The other nice thing about these systems, especially if you've automated this stuff, everything will be time-stamped. You'll know you ran the MITRE test from here to here on these times. So if the threat hunters think, hey, I think I might have found something, without pestering anybody, again, if this is set up right, they should be able to just look back at the little, deployment tool. Oh yeah, this is when they ran the MITRE attacks. It does line up with what I'm seeing. I can go now bug whoever ran them and verify that what I'm seeing does line up. So again, you've made this nice safe place. UAT has now become this magic sandbox for all this stuff, right? So UAT, think of it as no longer being for developers. It's now for the DevSecOps, right? Historically, it's been developers off limits. No one is allowed to touch it. We got to get rid of that, right? These 3 teams have to start working together. You have to test all aspects of these things. Like when I say test every aspect, like I'm not saying every aspect of the site, of the whatever the developer, your revenue generating application or website or whatever. I'm talking about you need to test your infrastructure, right? You need to test your testing tools. Test your SIM, right? Is it actually finding stuff? Because in the day-to-day process, you're probably not getting attacked so much that you're confident that SIM's actually set up properly. So you need to test those systems and automate when possible. If you don't automate, this stuff is really, really hard. So you'll get one guy that goes through it. You think you'll get the next guy to go through it? No. Automate it, right? There's tools out there for automating. We're starting to get more and more of that in the operations team. Please continue that. The more you automate, the more you get things in source control, the more you can make it repeatable, right? Again, I've had to do this before with software, not so much infrastructure. But if you have a release that goes sideways and everything is fallen completely apart to the point where you have to rebuild VMs and all that stuff, how do you deploy the last known good version of your software if you don't have a deployment system? You know what I was able to do? I was able to go to my little dashboard and click deploy version 3, and it went up. I don't have to do anything else. I went to get the VM up and running, it did everything. These systems are just lifesavers. Like, they're just amazing. So make use of those systems, okay? All right, useful resources. Okay, just some screen, or well, URLs, I guess. The MITRE ATT&CK, there's the link. Again, they're just OWASP, their source code analysis tool. The second one down, that's the Invoke Atomic Red team. That's the tool that will run the MITRE attacks. Okay, so if you guys want to get a photo of this, please do. I'll wait until I see all the cameras go down before I switch it. Still a few folks. I'll get a drink of water. Spill sometime. Okay, all right. Next one, same idea. So these are Splunk resources, not just not like the other ones were just kind of all over the place, open source resources. But so Splunk Lantern is an amazing place to learn not just Splunk, but to learn these concepts. Learn what a SOAR is. How does it work? What's a SIM? How do you just set up a SOC? Lantern is just it's a general purpose, amazing spot. Splunk has a surge team. That's our security response team. Anyone can sign up for their alerts. You don't have to be a Splunk client. Anyone can. They were probably one of the first groups that released a blog post on how to find and mitigate Log4j when that happened. They are a really talented team, and everything they do is just kind of released into the security world. Even if you are a Splunk user or another type of log ingest type system user, they will release searches. If they find something, they'll actually post the searches that you would use in order to find things. So it's a really, really good resource. The user groups, events for students, the events and the free training are probably really, really good. The events, they actually do a lot of hands-on workshops. There's a lot of just marketing things, whatever, but there's a lot of workshops where you can actually, they will spin up like an environment in a cloud world for you where you can poke through these systems and try them. And Splunk, I don't have it up here, but Splunk also does something called bots. I don't know if anyone's done a bots event. Yeah, they're fun, right? So yeah, if you ever see on the events.splunk and there's a bots event, please, I highly recommend. They're a capture the flag event, essentially. But they always do something really fun. They're really cool. It stands for Boss of the SOC. That's what it stands for. That's a silly thing. But anyway, I am out of time. And yeah, so thank you so much for attending. If there is questions, I can maybe answer one or two before they kick me out of here. Anything? No? All right. Oh, yes.
I guess like my question is how, like, we're all students, so how high would you prioritize like learning a SIP or like a 6 months?
Okay, so the question was for the students, you know, should they specialize on a vendor product, essentially is what you're kind of getting at, right? That's a tough one. They're all similar enough that if you can get access to one, learn it. The problem with some of these is if you're a student, you're going to get the open source one, and they're hard to set up. Like the open source ones kind of depend on, I have 5 other IT guys helping me, right? And that's not always the case. Some of them are pretty good, but that's why I had the thing for the events, the link, and there's other vendors that do these too. But when they have those events, they typically will have what they call workshops. So that's the key word. Look for a workshop, and that typically means it's a hands-on item, so you can actually go in and play with those tools. But I wouldn't get too fussed about, I only ever used this one or that one, because when it really comes down to it, they're all pretty similar, really. Yeah, do you have a question? Nope. Okay. Anything else? I think that's it. So thanks, guys. I really appreciate you attending.